Hi, smart students. Welcome back to the Engineer Squad channel. Today, we will continue practicing problem about parabolic motion. A ball is kicked at an angle from the ground. The trajectory of the ball reaches a maximum height of 45 meters above the ground. How long does it take for the ball to land back on the ground after being kicked? Ignore the air resistance. To answer this question, we will draw a free body diagram. The ball has an initial velocity, v0. This v0 can be broken into vx in the horizontal direction and vy in the vertical direction. From the problem, the maximum height is given. So, our analysis will be focused on the velocity in the vertical direction, or vy. This animation shows the motion of ball along its trajectory and the motion we analyze on the vertical axis. When the object moves upward, it takes a certain time, which we denote as t. And when it moves downward, it also takes the same duration of time. We will analyze the motion as the object moves upward. The height or distance in uniformly accelerated motion, h, is equal to v0y times t, plus or minus 1/2 multiplied by acceleration g and multiplied by t square. We substitute h with 45 meters. v0y multiplied by t. And, because the motion slows down as it moves upward, we use a negative sign. The equation becomes: we still have two unknown variables, v0y and t. We will find the value of v0y by analyzing the object's vertical motion. We remember that, in uniformly accelerated motion, vt equals v0 plus or minus acceleration multiplied by t. Where vt is velocity at t, v0 is initial velocity, and a is acceleration or deceleration. At the peak, the velocity vt is equal to 0. This initial velocity is what we are looking for. Since the motion slows down as it moves upward, the sign of the gravitational acceleration is negative. We replace gravity with 10 meters per second square and multiply it by t. Therefore, we get v0y equals 10t. Before we continue, we would like to ask you to like this video and to subscribe to the Engineer Squad channel. Your support means a lot to us. Thank you to those who have supported us. Now, let's proceed with solving this question. We will substitute the value of v0y into the height equation. It becomes: and we get 45 equals 5t square. We can simplifying it. Becomes t square equals 9. Thus, t is plus or minus the square root of 9. Or t equals plus or minus 3. Since time cannot be negative, we take t equals 3 seconds. 3 seconds represent the time taken for the ball to move upward. The time for ball to fall back down will be the same, which is also 3 seconds. So, the total time the ball being in the air is the time to move upward and the time to fall, which equals 6 seconds. That's the explanation for this question. Even though we didn't know the initial velocity and only knew the maximum height, we could still calculate how long the ball stays in the air. Thank you for studying diligently. We hope this video is helpful. See you in another physics problem discussion.